Hi, this is Dr. Schulman, and this video is going to be on curriculum and sequencing lessons within a unit. There's a lot of pieces here that I think will be important, but the general idea is really how best to plan out the way that you want your curriculum to fall. Now, I know in the introduction, I showed you different ways to structure it. But in this video, I'm going to be giving you just ideas of how to actually do it and what it looks like with a number of different examples. So I'm going to share my screen, and we are in Math for Teachers. And I think I'm going to combine one and two and just put it all in one piece for everybody. So Math for Teachers, introductions, pre-test, we did sequencing of examples in a lesson. Now this is lessons within a unit. Okay, I'm going to move this to the side. And these are some of the examples we're going to look through. But basically, what I want you guys to think about is how to build a unit. Now, just like we did in the examples, like for the lessons before, like we were doing like easy to hard for examples in a lesson. In this one, okay, in this one, it's all about making connections and building skills. Feel free to chunk, and chunking is breaking down a standard into multiple days. Now, what I think is a great idea, because the main problem that usually happens is there's so many standards. When we look at the Common Core, you're going to see tons of standards that you have to cover. When you look at the exam for New Mexico or any of the state exams, you'll see that there's so many things we have to cover. Usually there's like over 100 standards, no matter which one you get to look at. When you have that many standards, usually teachers try to shove them all in together, do at least one a day, and it starts feeling like a mile wide of information, but an inch deep. Now, what does that mean? It means you're trying to cover everything, but you do it so shortly that a lot of students don't really understand it because you're going too fast. I want you to resist doing one standard a day, doing 1 to 3 standards a day. Because a lot of times we can't resist that, whether it's our supervisor, the people in charge are just like, you have to cover everything that's going to be on the exam. But when you try to cover everything so fast, a lot of times students don't get it. So really think about taking a standard and having students tackle it, tackle different parts, and do projects. And we're going to do a project-based learning one. And my students have always told me that the projects we've done in classes help them actually remember the most things in mathematics. And you'll see a lot of the projects when we get there. So this is kind of the idea. Um, I usually backwards plan from the exams themselves and kind of build it. I try to grab a number of different ones that other people have made for their unit plans, and then I'll show you kind of mine. But let's start. So this is a first idea of a unit plan. So this is a 6th grade math unit 1. They're saying they're going to cover 3 weeks of study of numbers, and this is from a Yes Prep. All right, so the category name is numbers, operations, and quantitative reasoning. These are all the strands that they're going to cover. And these are the actual standards. Use addition and subtraction to solve problems involving fractions and decimals. Use multiplication and division to solve whole number problems. Use order of operations to simplify numbers without exponents problem solving. So the words that they're going to cover are use, solve, simplify, evaluate, add, subtract, multiply, and divide. I'd probably actually have definitions here if it was mine. The concepts are problem solving, addition, subtraction, multiplication. And unit one will address the operations with whole numbers, no decimals and fractions. We will also focus on problem solving in world and application problems. So this is pretty much everything that they're planning to cover for 3 weeks. It's their unit. It's probably going to end with the test, and they're backwards planning from these standards right here, 6-2. And then they also have how students are going to demonstrate mastery. So will they be able to solve this word problem, this PEMDAS problem? Which one is prime factorization of 80? Thinking of two numbers, the greatest common factor. So this is all stuff that we're going to cover in here. I like that there's lots of word problems in here. Which of the following is not a common factor of both 24 and 32? Is 16? 16, no. 16 isn't 24, so 16's out. But yeah, we basically just have to figure this is 8. 8 works, so A is here. 3, so this is 2 times 2 is 4 times 2 is 8 times 2 is 6. Yeah, it's not 2 either, so this one's just 1. But yeah, these are and simplifying fractions. What's the greatest common factor, the numerator and denominator? I'd cross out the zeros and just think about 9 and 42. Where do they match? 4 plus 2 is 6, and this is 9. 3 goes into both. I'd go with 30 here. I think 30 is the answer because 60 doesn't go into 90, so it's G. That's numeration. In case you want to see this, can I draw on this? I'm going to see if I can download and draw on this thing for you guys. Just so I can show you some of them. And then we'll get into it. And so in case you want to do this one, it's 3 plus 2. I got to draw. So 3 plus 2 is 5. 5 squared is 25. So I have 25, and then I have a plus here. I got a 44 minus. So I gotta multiply this first. 2 times 3 is 6. So I'm left with 44 minus 6. This is just PEMDAS. 44 minus 6 plus 25. 44 minus 6 is going to be 38. What's 38 plus 25? And that is going to be 13. Carry the 1. I got 63. So the D. If you have this for yours, I would probably do what? I'd probably have this an answer key. I'd probably have these answers done. Jerry's thinking of, I'll just do the right side. Jerry's thinking of two numbers. Their greatest common factor is 25, and their least common multiple is 150. What is the other number? So this is 25 and some other number. So greatest common factor is 25. So I have 150, and I didn't know the other number. Oh no, so the GCF is 25, and their least common multiple is 150. So 25 has to go in. So what is the other number? So we know it can't be 10 because 25 is not a factor of 10. 25 does not go into 55 either. So right away, just because of greatest common factor, we knocked out these two. And one of the numbers is 50. So we still have to figure out the other number. So the least common multiple. So if it's 25, it'd be 25, 50. So 50 would match. So that's why it can't be this one. Least common multiple just means the number where they first match. So 50, 100, 150. These are just multiples of 50. This one's 25, 50, 75, 100. So it first matches at 50, not 150. So this one's out. 75 All right, so 75, 150. Oh, we're already there. Perfect. So the first time these two matches, their least common multiple of is 75, 150. Yeah, it's got to be this one. Their greatest common factor is 25. Yeah. Oh, because this one, their greatest common factor is 50 and not their greatest common factor is 50 and not 25. So J is your answer here. Scott has 13 dog treats. He wants to share them equally among three dogs with no treats remaining. Which of the following cannot divide the treats evenly? Which of the following is the reason he cannot divide them evenly? 13 is not an even number. That's not why he can't divide them evenly, because it's 13 and 3. So 13 is not an odd number. I like 13 is not a multiple of 3, or 13 is not a factor. It's really trying to understand what the difference between factor and multiple is. 13 is not a multiple of 3, and 13 is not a factor of 3. So which one's the right answer? Yeah, I don't like either. I think it's this one because 13 is not a multiple of 3 because it goes 3, 6, 9, 12. I think that's the good reason. I actually like C and D for both of these, but I'm going to go with C. Jeremy is practicing factorization homework. She needed to find the prime factorization of 1350. She tried the problem several times, and each time she had a different answer. Which one is correct? So prime, when I say prime factorization, it means it cannot be broken down anymore. So right away, this is 25. That's not a prime number, so A is out. This is 9. That's not a prime number, so that is out. 2, 3, and 5 can only be divided by 1 of themselves. 2, 3, and 5. So it's got to be one of these three. So we just have to see which one makes 1350. Well, 3 times 3 times 3 is 27 times 25 times 2. Let's just try the first one. 5 squared is 25, so it's 27 times 25 times 2. And then I'll do the bottom one, and then we can look more at this. Whenever there's math, I always want to show you how to do it. So it's 25 times 27 times 2, 1350. Sweet. I had a feeling it was this answer. All right, so let's just do one more, then we'll get into it. So I wanted to show you how I did 10. This was the main reason. So the first thing I did, I was crossing out these zeros to make this thing look clearer. So I just know I have to put a 0 at the end. So if everything has a 0 at the end, I can literally cross them all out. Isn't that so nice? So I just have just to make it smaller. So if we have like 40,000 over 10,000 and you're like, oh my God, this is such a big number, you can show your students to go psh, psh, and it's just 4. The zeros match, same thing, zeros in questions, zeros in answers. It's really helpful to move. So 9 over 42. I did 4 plus 2 is 6. And I did 9 plus 0 is 9. And I know 3 went into both. That's why I believe 3 is the answer. That's how I did it in my head. Now we can do 6 goes into 42 7 times, but 6 does not go into 9. That's why it doesn't work. 2 goes into 42 but doesn't go into 9. 9 goes into 9 but not 42. And 1 is not the greatest. So that's why it's G. I really just did the problem to show you 10. All right, here's some more. That's okay. All right, so let's actually see what this does. How do I, a skilled learner, reach and exceed this expectation? Demonstrate mastery. These are just some nice pieces. So upon completion, store the record on Dropbox. So it's just showing like how they're gonna prove that the students hit the marks. These are daily objectives. I really like this. So divisibility rules, this is what they're going to do every day. So this is what I mean by planning it out. So the first, they just learn and apply the rules of certain numbers. They don't do all the divisibility rules. Then they do these numbers. So they're breaking down this standard divisibility rules to 6.1 into not one lesson, but 3 lessons. That's a good unit plan. It's basically, it's like you don't want to give students word problems which are real tough right away. You want to start them with something small, have them understand things, and then build them up to word problems or build them up. Let's see, exponents, standard 2 exponents. They're doing 2 standards, but they're spending 3 days on that, which is nice. So square numbers and geometric models, identifying square numbers, evaluated an exponent notation. So we're taking this idea of exponents, which they learn like a million times, but we're at least doing 1, 2, 3 days on it, trying to make it more challenging as they go. Operations with and without expression. So this is just one standard, and they're spending 4 days on this, which is great. So why it exists, why it must be followed. Okay, and then they're doing this whole thing into different pieces. And this SWBAT, that just means students will be able to. And they've got the standard, they've got is it simple, complex, or transfer skills. They're saying how strong it is and what type of learning target. So that's what all that stands for. And then we got prime factorization, factors, multiples. If there seems more tables, you may devote a subsequent unit of study for this one. So everything is broken down. Re-examine the objectives. So these are essential questions. Without order of operations, how would the world be different? I like these discussion questions. This is relating things to everyday life, which we'll do a lot of. And here's our calendar. Okay, so the main thing that you'll see a lot of, I've made tons of calendars. I think calendars are probably the best way to do it. You'll see exactly how long they're spending on each piece and what's in it. Your unit plan can just be this calendar, okay? But how do you build the calendar? I always use either the standards, which are up here, whatever standards they're going to cover, as well as whatever tests. So the standards and the tests work backwards, and I'll show you different ways to do that. So let's look at their calendar. So rules, expectations, procedures, divisibility rules. They only spend 2 days on division, which is okay. They spent 1 day on exponents. Oh, sorry, 2 days on exponents. And then they have 2 days on prime factorization. I probably spread this out a little bit more, but you know your students. You'll see how much time you think they need, and don't be afraid to be flexible. I think being flexible is the big key. Leave some extra space in here. If you think the student's going to struggle with stuff, have it there. Notice that they have the quizzes here. So this is where they're going to be doing their formative assessments. And then you've got the summative assessment here. Always make sure what days are off for no school. And then finally, you've got your main summative assessment with a review day for the quiz and a unit exam. So this is a pretty standard calendar. But how do you build it, right? Always try to do easier stuff before word problems, by hand before graphing, or try to do them all at once. I think there's enough space here. At least they're not spending just 1 day on everything, which I like a lot. See, we got greatest common factor for 1, 2, 3 days really. So really think about how long you want to spend on these ideas as you go through it. Okay. And the main thing that we're going to go next time is the possible misunderstandings, because this is going to come up all the time. You must divide or add before you subtract with multiple operations. When taking the square root, the perfect square and geometric model does not change. So square roots, everybody's going to divide. You'll see that mistake a ton of times. So I know this is for like the next one, but the most common mistake you're going to see is when you see 81, most people just divide this by 2. You know, they're going to get 40.5. That's why I try to actually have them build a square out of it. Oh, sorry, I built a cube. That would be if it's cube root. So if it's square root of 81, have your students actually build the square and have them think about what number times itself twice gives you that. So it's 9 times 9. I think that's going to be the best way. And you can even have your students break this down into 9 chunks and count the 81 boxes. Those are just try to make the symbols tell them what to do. Square root, guess what it means? Side of square. Okay. Any number with an exponent of 0 is equal to 0. So they're saying if it's 5 to the 0 power, a lot of people say 0, but anything to the 0 power just means we have one group. That's a common mistake. When dealing with the exponents, the base numbers multiple. Oh yeah, so they're saying if we have this one, which is another common misconception, is if we have 3 squared, a lot of students might do 3 times 2 to get 6. However, this is a square. That's why it's up there. So it's 3 times 3. And we have 9 boxes. All odd number. 1 is a prime number. Nope. 1 is not a prime number. And all odd numbers are prime because 9 is not prime. Because it can be 3 times 3. A lot of odd numbers are prime. That's why students make that mistake. Awesome. So there's the first unit plan. I know this one's really long. I just found one that I thought was really well done by the School Yes Prep. So let's look at another unit plan. This is from the same school, but now it's data analysis. So I did the first unit and the last unit. Why? Because these are stuff that we're going to cover in this course. So we got probability and statistics, supporting strands. So sketch and graph circle graphs. So they're saying S is for supporting and R is for readiness. That's their own pattern. So this is the standard. Solve problems by collecting, organizing, displaying, and interpreting data. So here it is. Ta-da. And then we have 8.12, construct circle graphs without technology and use stats to analyze data. A lot of times these are left out, the statistics, but we're not going to. So like before, they're giving you some word problems. Okay, so I might as well show you how to do a couple of these before we get into it. Oh, good. There's barely any problems here. So, what is the median temperature in December at East Middle School? Students plan to record the temperature every day of the month. So they want the median. Median means middle. Median means middle. That's what it means. I was going to download this so I could write on it. All right, here we go. Here's West Unit Plan 9. Then we'll look at some other ones. So this is basically just probability and statistics, 6.10. This is the standard that they're doing for 6th graders. So if they want to do the median, which shouldn't be too crazy, they want to do the median, that's the middle number. So list the from least to greatest, and the middle will be the 16th value. How many days are in the month? Every day for the entire month. It doesn't give us that. A line plot point. No, it's not a line plot. Adding all the temperature values. So this is the average or the mean. Then a leaf plot, the longest one. Nope, that's not going to do it. A pie chart, no. So it's A. It's the middle temperature value. That's all. They're just trying to get the name. This is 420. The graph below is the breakdown of 7th grade girls. How many of the middle schoolers are 7th grade girls? Okay, so 7th grade girls is this amount. So we don't know. There's no percentage here. However, we know this is a quarter, so that's 25%. The whole thing's got to equal 100. And this is another, so this half is 50. So I know the top is 50. The bottom is 50 minus 15 minus 15. So what's 15 and 15 is 30. So 50 minus 30, so this is 20%. Now there's 420 of them, so it's always what you want over the total. In our case, we can put this over 100 and cross multiply, but it's just 20% of 420. So you could just do 420 times 20%. Isn't that so nice? So 420 times 20%, because we're dividing it by 100, 0, right? So that's 0. 2 times 2 is 4. 2 times 4 is 8. Now, if I'm going to be 8,400, I have how many decimal places? 1, 2. I have 2 here. So how many students is it? 84. So that's one way. When it's 20% of in math always means to multiply, and that will give you the right percentage or answer. Cool. I'll skip this one. What is the median? Are these in order? Cool. I'll at least do this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there's a formula for this. It's just n plus 1 divided by 2. 22 plus 1 divided by 2, 23 divided by 2. Our answer is going to be 11 and a half. If you're not sure, 23 divided by 2. Oh, sorry. It's 11 and a half. So we just need between the 11th and the 12th. So what's between 11 and 12? 76 and 78. So it's 77. All right. These are the standards. These are the essential questions, data in different formats. And here's the calendar. They made this really short. Usually a lot of time is never spent on this. And I just wanted to show you how short the unit can be made. Central tendency, graphical exam. I don't know if there's enough time here to really give students information. I assume this one will be really short, but this is how the calendar looks with the objectives of what they're covering each day. I'd definitely do a project for this and have students use their own data and own numbers. All right, so we saw one setup. I might as well show you some more. So here's another plan. So I know this is a high school plan, but it's basically getting into high school. So they're using, this is the context of a summer school, trying to make an assessment problems that show the level of rigor on the end of the institute assessment. So they've got a goal. 100% of the student will reach the goal. They're going to do this using this ISAT exam, 4-unit plans, and then they've got big ideas. I like this. Big ideas, understand geometry, the concepts of congruence, similarity, symmetry. So all these pieces I think are really helpful. And then they're using the Common Core mathematical practice. So throughout the whole unit, they want to make sure the students are making sense of problems, reasoning abstractively, constructing viable arguments, and then they're going in depth of how they're going to see these elementary students constructing arguments using concrete pieces, because these are students getting into high school. Model with mathematics, there should be modeling happening. Use tools, attempt to precision. So this is every standard, and trying to be as specific as they can, using examples within it. Your unit plan does not need to be this specific. So these are the standards addressed in the unit. They want to do this one, which is angles of circles, perpendicular lines, prove things about lines and angles, theorems about angles like side angle side, and derive the equation of a circle of a center using Pythagorean theorem. Okay. Nothing too crazy, but this is what they want to cover. These are the standards, and these are the essential questions they're going to be asking throughout it. Now, the way that they're doing this is that they're actually going to have the sample ones within the objectives, which is totally fine. So which one's the notation for a line? This one's a line. I'll download it so I can write on it. So this one, so notation is really important with geometry. So notice that this one has 2 arrows. That makes it a line. This one's a ray. This one's also a ray, and this one's a segment. Notation's really important. It shows that the line stops one direction forever, and this is in both directions. Label two line segments and one ray. BD is a ray, starts from one point and keeps going. A line segment is IK, it stops. Notice that there's no arrows on this, and CF stops. This is the only one with a little arrow. So these are just acute, right, and obtuse angles. I'm going to see if there's a calendar. But this is just another way. They have the objective here and they have the example. There's other kinds of angles too. There's not just acute, which is less than 90, right and obtuse. There's also ones like this. This is called a reflex angle. It's between 180 and 360. Then you have a straight angle, which is a straight line, which is 180. Just so you can get more information. Okay, so these are just all parts of geometry. And they get to do a plan, which just sounds nice. So that was just unit one. And then we have unit two. Oh, this one's a definite common mistake. Students mess this one up all the time. So I might as well show you this one too. This is a very common test question. So if I'm 8 on one side, I'm 8 on the other. If I'm 3 on one side, I'm 3 on the other. But how big is the top? Top is actually 4 plus 5 plus 6. So that's 10, 15. So the perimeter is all the way around. So it's 8 plus 15, which is 23, plus 8, which is 31, plus 6, which is 37, plus 3, which is 40, plus 5, which is 45, plus 3, 45 plus 3, which is 48, plus 4, which is 52. I usually mark where I start so I don't count that 8 again, but I saw 8, 15, 8. So this answer is 52. A lot of students forget this piece or they don't add this piece because the numbers aren't there. That's a common mistake. And this is working backwards. The whole perimeter is 23. So it's 2x plus 2 plus 3x minus 1 plus x plus 4 equals 23. 2x, 3x, x, 6x, 2 minus 1 is 1 plus 4. So it's basically 6 minus 1 plus 5 equals 23 minus 5. So 6x equals, well, what's 23 minus 5? That's 18. What is x? That is 3. So this one's got to be 7. 3 times 3 is 9, minus 1 is 8. 2 times 3 plus 2 is 8. So this is what's called an isosceles triangle because it has two lines that are the same. And we know that these are both equal to each other. Isn't that so pretty? And we have to classify it like it. And then we just did this one, but now they want to do the area. So you could do the area of the whole piece minus the box here, because that's not part of it. Or you can cut it like this and do 1 box plus 1 box plus 1 box. I think it's easier to do the whole thing minus the little box. So the whole piece is 8 times, we did this before, 15. This one's 3 times 5. So the area is 15 on this one, and the big one is just 15 times 8. 0 carry the 4. 8 times 1 is 8, so it's 120 minus 15. So the answer to this one is 105. All right, well, I could do all of them. This is the box minus the triangle, but because it's half the size, it's 1/2 base times height. And then you just multiply that and subtract it. So I could do them all, but that's okay. If you want me to do more, I can do more. Nothing's crazy. This is Pythagorean theorem. which is a squared plus b squared equals c squared. And you just substitute the pieces in. So it's going to be 5 squared plus 2x squared equals 3x squared. So 5 squared is 25 plus 4x squared, because the 2's got to go to both. And this is going to be 9x squared. So we minus the 4x squared to both sides. We got 5x squared equals 25. We divide both sides by 5. X squared equals 5. Square root, square root. So what is x? X equals the square root of 5. I know a little tricky, but some of them get a little weird. So this is 2 root 5. And this one's 3 root 5. All right. And then here are all the transformations. And I could do them all, but I'm sure I'll be doing them in the geometry units. Similar figures, same difference. So, and then there's a project. So I don't like this one because there's no calendars here, right? I like having the calendar too. It just has what they need to know by the end. It doesn't say how long you're going to spend on each of them. So I think that's a big problem with this one. So I don't really like that one. So let's actually look at this assessment plan and kind of see how to do one of these and then look at the standards. So here we go. Now this is towards the end. You can do this assessment assignment if you like. If you don't want to do it, that's okay. So this assessment assignment will challenge you to develop 5 phases of a specific Common Core standard or other mathematical standard. You could take it from a high stakes exam. So this is the elementary school exam for New Mexico. This is the MAP testing. It's pretty national for nationally used elementary school exams. I'll go over the standards of each. And you should select one question. So just take one question you want them to be able to solve. This is how you backwards plan. Then you research the specific math standard that applies to it. So go into the Common Core, be like, okay, which one matches up to this? And then use the standard as a specific question as a guide to backwards plan a series of assessments to best prepare the student. So we write the high stakes exam question, we write the standard, and then how do we backwards plan? So what is the unit exam for that going to look like? Are you going to do a weekly quiz for that? Are you going to do a daily exit ticket for that? Are you going to do a daily do now for that? And are you going to do an in the moment check for understanding? So how can we take the test question, right? The final exam question that meets that. What would the weekly quiz look like? What would at the end of that lesson look like? What would just a do now like? Can you remember how that works? Like, what do they need before that to be able to solve it? And then the in the moment check for understanding. So this is like kind of the big piece. So here, let me download this so I can draw on it for you guys. So this is like kind of like the big piece. So whatever standard, and this is a great way to backwards plan or set up your unit. So whatever question you have, right? Whatever this question is, it could be something as simple as 2x minus 5 equals 10, right? Nothing crazy. How do they solve that? You know, what standard is this? Well, we can look up the Common Core standard, but I'm sure it's algebraic something or other, and we'll do one. But what does the test look like, right? How will they be able to solve this on a test? What would the test questions look like? After they've gotten all the information to be able to solve a problem like this, you could be like, okay, what does the quiz have? What does the quiz have? What does it look like the end of that day? And this one is just going to be like, what pre-skills do they have? What pre-skills do they need? And to me, this would be PEMDAS. They need a PEMDAS do now to get to here, right? Like what do they need before to solve it? And in the moment checks for understanding, I always do things like fist to 5. And a fist of five means the student holds their hand to their chest so they don't show everybody else. And zero is I don't get it. One is I get it a little bit. Two, I kind of get it. Three, I'm almost there. Four is I'm just about there. And five, this is the easiest thing in the world to me. And so that's how I check for understanding as I teach the subject. So they can hold their fists in their chest and then they could show me the numbers. Teachers like thumbs up, thumbs down, raising their hands, nodding. There's a whole bunch of ways you can check for understanding in the moment. I give you information about the summative exam. One class period per see how many ways can you vary the question type, algebraic, geometric, word problem, graph application. So whatever standard, think about different ways you can vary it. What content standards are connected to the topic. So obviously we're not just going to be doing this in the unit, right? If this is the standard, it could be graphing this, it could be word problems of this. All of that will go into the test. You could have one with X's on both sides. You could have one that has fractions in it. Like, what are all the different ways that can show this problem? You can make a multiple choice, free response, project-based, or a combination of methods. And then how are you going to give the students the feedback? And this is the quiz. So the standard to prepare them for that summative exam. And then I just give a bunch of information about how to make a summative quiz. How do you limit cheating? How much does it count for the course? These are just things to think about. The formative, the daily ticket, a lot of people do this. It's the end of the class. Could be a quick fill-in, a match, anything to how to understand their answer and how to go back from it. Are you grading them? How much is it worth? What's the accountability? And then we've got the formative due now. So what's the difference between this word formative and summative? We'll do a lot of this throughout it, but formative means like kind of in the moment at the end of like the day. Basically, the formative is really fast. It's like, how can you check that they're understanding? It's a check for understanding. While summative is like you put a bunch of topics together and then students show you what they've learned. That's the difference. One's to sum it up and one's to form that understanding. All right, and these are just components of the assessment. And I built this based on standards. So these are the standards. These are the INTAS standards, which kind of show everything that you need for your students. And then I also use the NCTM, that's the national principles. So we might as well go into Common Core and actually look at some high stakes testing. And that's the best way to end this piece. So here's the Common Core standards. This is for national. Some states use their own, but this is kind of what it looks like. So this is the Common Core standards for mathematics. You click on it. It's got the standards, and then we have all the grades, grades 1 through high school, and these are all the parts of high school. I've taught basically every one of these, which is made up of these. So I know most of the standards. Here's an introduction. Let's just go into like grade 3 or something. Numbers and operations in base 10. This is a grade 3 standard. Use place value to understand whole numbers to the nearest 10 or hundreds. Fluently add and subtract within 1,000 strategies. Multiply one-digit numbers for 10. So 9 times 80, 5 times 60. So this is the standard. What should they be able to do? Are groups of related standards. So they have these things called clusters that you'll see. And these are larger groups related to the standards. So I'll show you what some of these look like. The standards for practice is just what nationally we think they should be able to do in math class, make sense of problems and persevere in solving them, reason abstractively and quantitatively, construct viable arguments and critique the reasoning of others. This is huge. You should definitely help your students be able to talk a lot, and that comes a lot from normalizing mistakes. That's a big piece here for normalizing mistakes. And one of the biggest things I think that this goes here is bidirectionality. Make sure you're not the only one who has the knowledge. Are there faster ways? Are there other ways? Think about how much you can learn from your students. This is like the biggest piece. If you keep this piece going, it's going to make so much sense. Um, and then we've got modeling with mathematics. I've got a whole thing on making models and use appropriate schools, attend precision, look and make use of structure, look for express repeated reasoning. Okay, so we finally made it here. This is per grade, everything they need to do. Okay, this is what you're supposed to be able to do by the end. If it's in kindergarten, you got 8 things. Oh, sorry, no, those are just the 8 regular pieces. I make mistakes all the time. What do we got? We got counting, 1, operations and algebraic thinking, numbers in base 10, measurement and data, geometry. Okay, so this is it. Each one of them have little pieces, but that's all they should do in kindergarten. And then we have each of these standards. The K-means is starting at kindergarten. This gives you a little bit of information about it. And they also have pieces, represent addition and subtraction with fingers, clapping, all these little pieces. But these are the standards. Geometry is identifying shapes. Oops, sorry about that. And here's grade 1. Okay, so grade 1, we got 4 critical areas: addition, subtraction, whole number relationships, place values, developing understanding. And these are what the standards look like: algebraic, base 10, measurement, and geometry. So each one of these goes a little bit more in depth. And communicative properties, associative properties. So 8 plus 3 is the same as 3 plus 8. 2 plus 6 plus 4 is the same thing as 2 plus 10. Adding and subtracting. So you could just look through these base and work backwards, right? Be like, I have to cover these pieces, and you can work backwards for it. Same thing with grade 2. We got grade 3, and it goes on, keeps going. Every one of these kind of looks the same. That's this cute little overview in the beginning, which is basically multiplication, fractions, structured arrays, an area, and 2-dimensional shapes. Okay. So it gives you a nice little overview, and then it goes into each one of these pieces. But you have to build it from here. You have to build your units from here. You have to build your tests from here. So I like actually looking at main test questions. What do the students need to do, but at the very end and work backwards. So as soon as my computer loads, here we go. All right, so let's look at map testing, and then we'll look at yours. So map testing is the one that's used a lot across the nation. It's got free sample tests, right? Sample test questions. It's usually used K through 2, 2 through 5. I've never really seen it 6 through 12, but it's usually used for the younger groups. This is the way the math works. They can start practicing now, and these are the topics. So let's say we just went to numbers and operations, because this is what we're looking at. This is what's in here. This is everything that's going to be covered in this. Let's say it's operations and algebra. Here are the topics. So you can use the test that they're going to take at the end, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 units, and you can work your way backwards, right? If you're going to do all of these, if in your class you have to do all 5 of these could be your units: 1, 2, 3, 4, 5, 6 units, and you can work backwards. And these are the scores. There's the score range. That's fine. Here's a sample question. So choose the sphere out of the 4 shapes. We know it's A. This is a cube. This is a cone. That is a cylinder. Putting an X on a cupcake means it is taken away. Jordan, X on the cupcake to show 6, take away 2. 1, 2, 3, 4, 5, 6. X, and then there's the 2. Oh, sorry, show 6, take away 2. So 2, then you cross that out, X. And then I believe you have 4 left. And this is comparing of shapes. What are they asking you to do here? It doesn't actually give you the question. Are they asking you what are the same? I would see the question here. There's the answer is B, F, and H. B is a triangle, F is a triangle, H is a triangle. I guess they want to know which ones are all triangles. This is a square, that's a trapezoid, that is an oval, that is a circle, that is a pentagon. So these are what these questions look like. If you want to look up free samples for 2nd grade, for 5th grade, and then you can work them out and they have the answers here. So you can use this to kind of build your test, to build your test questions like it. What do they need to know to be able to do it? What's the pre-skills? What's the post-skills? So I think this one's really good. What a lollipop that costs 53 cents paid with a $1 bill, which shows the change. Well, $1 minus 53 cents is 47 cents. So that's 25, 50, 61 cents. Nope. 25, 35, 45, 46, 47. I like B. 25, 30, 42. 42 is not enough. 25, 30, 35, 36, not enough. I'm going B. And it is B. So you can work backwards from that test. Now, here in New Mexico, this is probably the test that they're going to be taking. It's called the NMMSSA, the New Mexico Measures of Student Success and Achievements for Mathematics. And we can work backwards from this one. This is the end of grades 3 through 8. So that's why I thought this would be the one that we would be looking at for being an elementary school teacher. Grades 3 through 5. So what are the things you have to do in grades 3 through 5? Operations and algebra, numbers and operations and fractions, measurement and data and geometry. So I would make my units these 3 ideas. I'd probably break this one into 2, measurement and data and geometry into 2. I'd probably break out number operations and algebraic into 2, and I'd break this one down. But it's up to you. You can set up your units how you like, right? But you want to make sure they get exposed to this. And let's look at a test. Which one? Geometry has the least, so maybe spend the least amount of time on geometry. Which one has the most measurement and data? So I'd probably spend the most time on measurement and data and numbers and operations. Oh, no, this is the most. Algebraic thinking and operations. So that's what would be the most. Notice that it switches each time. They're about the same. So know the test that they have to pass, know what they're going to be exposed to. Use this to break it down. Let's see if there's a practice test in here. It doesn't matter if we have the practice test, we have the standards, all the standards in grade 3. Sweet. So that's everything that's in it. That's how fair the test is. Basic, and they get scientific calculators later. Basic just gives them plus, minus, multiply, divide, square root, positive, negative, and percentage. Assuming this is the advanced. Yeah, because you can do sine, cosine, and tangent. They get rulers and protractors. That's nice. And if you want to learn more about these, which are really useful, you could do the tools one, which goes through exactly how to make lessons for each of these. How to make a lesson with a ruler, how to make a lesson with a protractor. Okay. All right, so we get a question. So it's sweet. So this is how I would do this. So here's question 8. Well, let me solve whatever this one is, and then we can work backwards. So this is the number and operations one, right? So if I were to make a unit, I'd have to have my students know about a number line, know how to read a number line, know about subtraction, and these are absolute value bars. So whatever in this always turns positive. So I have between -5 and 3, so the distance. So I have to figure out this distance. We can count, that's the slow way, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8. I need an 8 at the end. All right, so what is a -5? So what is a 5 minus a 3? That is only 2, not 8. 3 minus 5 is -2. Okay. -5 minus 3. So this just makes a -8 and its absolute value, which makes it positive. So C is the answer here. 3 minus 5 is -2, which is positive 2. So there's your answer. It's C. But how can you build a unit to do this? What would you need to have in it? Well, we'd have to teach them subtraction. We'd have to teach the students number lines. We'd have to teach the students absolute value. All of these things would be needed in the unit in order to be able to solve this question at the end. And then we could go to the Common Core to see the standard that they are using for this. We go back to Common Core, wherever it was. This is absolute value. It disappeared on me. Okay, let's try again. Here's absolute value, grade 6. Let's find the one with it. Understand absolute value in rational numbers. This would be 7.c. So this would be the standard that they're doing, 7.c. I'd write this in and work backwards, but they need more than just 7.c to solve it. They also need the number line. And the number line is, so this question's the 6th grade standard, but here's your number line. So it's, here it is. Here it is. It's actually grade 7, the number system. So that's where the Common Core thinks this should be. So that's where I would put that standard in. All right, let's do one more where you'd be able to work backwards. Okay, so name the two shapes that have equal lines of symmetry. So lines of symmetry just means you can fold it and everything matches. My students always love when I did these problems with a superhero logo, whether it was Captain America, which has like the star in it, not the best artist. And then they counted 1, 2, 3, 4, 5 from every point of the star. Okay, so we just have to see it match. So that's 1, 2, 3, 4. So if I were to fold this, I'd have 4. If I fold this, no, this is 0. So it can't be B. C has how many? 1, 2, 3, 4, 5, 6, 7, 8. So C has 8. This one just has 1. Another way to fold it, and this one just has 1. Okay, so this one's D and E. These two can just be folded one way. So what would I need to know? I need to know shapes, lines of reflection, lines of symmetry, what reflection is, and I'd probably build it with rotational order because that's very similar, where it's being able to spin around and look the same. How many degrees do you spin for me and it looks the same? And then there's word problems. There are 113 fourth grade students each. We got 2 slices of pizza. Each pizza costs $7. 8 slices. Okay. $113. Each student will get 2 slices of pizza. So that's 2 slices of pizza each. So each student gets 2. So I'll call the students X. And the pizza costs $7. Find an equation, number of slices of pizza the school needs to order. So it's 8 times S, right? 8 times S And each one of these is, well, we don't care that they're $7, just how many they're ordering. So 8 times slices, and each student gets 2 slices of pizza. So it's 8 times S times 2 and times 2. And then this gets multiplied by the 113 because there's 113 amount of students. So 8 times S times 2 times 113 equals S. So 8 times 2 times 113 equals S. So 8 slices, 2 each, 113 students. We don't need the $7. Now find how many pizzas. Write equation used for P. So how many pizzas you need to order. So now it's not 8, it's just 2 times 113 times, that's it, equals P. And there's 113 and each gets 2 slices of pizza, and there's 8 slices in each pizza. We have to divide this by 8. 113 times 2 slices, and there's 8 in each. So now we divide this by 8. I could have messed it up, but that's pretty much what you should do for those. Length of a rectangle, 4 units, 3 times its width. Oh, this one's hard. I might as well do this one, so the pizza one. So we have a rectangle. The length of the rectangle is 4 units more than 3 times its width. So more than means after the fact. So here we go. So the length of the rectangle. So the one we don't know about is width, so that's X. The length is 4 units more than 3 times width, so that's 3X plus 4. The perimeter. So that's 3X plus 4, and that's X. So it's X plus 3X plus 4 plus 3X plus 4 equals the perimeter. 1, 2, 3, 6. So it's 8X plus 8 equals P. Ta-da! The width is 10. What's the perimeter? 8 times 10 plus 8 equals P. 80 plus 8. 88 is the perimeter. Cool. So, all right, I could keep going. But that's the test that they're going to have to take. So what would I do if I were you? To build my units, for the test themselves, just be like, okay, what do they need to know first? Always do the regular problems before the word problems, problems without fractions before fractions. That's what you need. If I was going to be making a unit for elementary school, I would be looking at this exam, and I'd be looking at the Common Core standards, and I'd be building everything, all my units based off of that. So hope this was helpful. The next one we're gonna do is normalizing mistakes and finding common mistakes, which will be really good. And let me know if you have any questions.